In this lecture, we're going to enable some of the Sysmon events for all events on our assumed breached host so that we can see if we're collecting telemetry, analyze that telemetry, and see if there's some type of detection opportunities. We're going to focus on two events in this lecture, Event ID 1 and Event ID 3. Event ID 1 is your process creation event. The process creation event provides extended information about a newly created process. The full command line provides context on the process execution. If you think back to attack path level 0, there's some commands that we executed that we may want to identify, which is a key indication of some host enumeration. Now, with this event, the process GUID field is a unique value for this process across a domain to make event correlation easier. The hash is a full hash of the file with the algorithms in the hash type field. For event ID 3, the network connection event logs TCP and UDP connections on the machine. It is disabled by default, but we're going to enable it for all ports and both TCP and UDP. Each connection is linked to a process through the process ID and the process GUID fields. The event also contains the source and destination host names, IP addresses, port numbers, and IPv6 status. Let's jump into a demo and see how we can start enabling telemetry for Sysmon so that we can explore that telemetry and see if we can find some valuable telemetry to make detections from. I'm logged into Waza and I'm at the overview dashboard. As we progress through exploring telemetry, we'll also learn how to use the Waza manager. So I'll cover various components of the manager. Here on the overview, we've already seen the agent summary, where we've taken a look at where our active agents are, and we can also see if there's any disconnected agents. To the right of that, we get our last 24 hours of alerts summary. You can see I have 38 critical, 90 high severity, 7 medium severity, and 14,356 low severity. Under that to the left, I have endpoint security. This allows me to access to various dashboards related to endpoint security, like configuration assessment, malware detection, and file integrity monitoring. To the right of that, we have our threat intelligence group, where we can look at the threat hunting to browse through your security alerts, identify issues and threats in your environment. We can take a look at the vulnerability detection dashboard, which will allow you to discover what applications in your environment are affected by well-known vulnerabilities. And we have access to the MITRE ATT&CK dashboard, which will allow us to explore security alerts mapped to adversary tactics and techniques for better threat understanding. Below that, to the left, we have our security operations group, and to the right of that, we have our cloud security group. Now we'll cover more of these in more detail as we progress through the lectures in this course. In this lecture, we're going to focus on the blue team explore phase, where we're going to explore our current telemetry and identify telemetry gaps. Once we identify telemetry gaps, we're going to see if we can fill those gaps by enabling additional auditing, or in this case, we're going to enable different Sysmon events so that we can capture more telemetry to allow us to have the telemetry necessary to build high fidelity detections for attack path level 0. All of this exploration can be done under Explore, Discover. Now when I come here to Discover, it's going to automatically select an index pattern for me. An index pattern is a pattern that is created that tells Waza or Kibana inside of Waza how to decode the events that are collected in this index. And then it will parse that events, that data, into fields that we can use to search on. If you recall, we created the waza-archives-star index pattern. Now these are all managed under dashboard management, dashboards management, and then index patterns. Remember, we created this waza archive star. Now the default is set here, which is selected when we go to explore. We can change the default, but we'll leave it to alerts. If I click on waza archives-star, we can see here is our time field, which we selected timestamp. And remember, this has a decoder associated that we selected, and that tells waza how to parse this data. Now, as we add events from Sysmon, there's going to be different field values that are not currently decoded or represented in this index pattern. What we can do is click this top right to refresh the field list and hit refresh, and that will kind of re-decode or recheck all the data to make sure all the fields are getting decoded properly. Let's go back to Explore, Discover. To the right, we have a timer that we can pick either absolute, relative, or we can just select now. And we can change this time to various times to set the start time to look back for. So I'm going to look back 12 hours. Once I have that set, I'm going to hit update, and it changes the number of events that are searched. Let's jump over here and go to the waza-archives-star index so that we can search for Sysmon Event ID 1. Now here is the search bar, which allows us to write DQL, Dashboard Query Language. You'll want to make sure you have the reference for the dashboard query language open until you become super familiar with the syntax. Now think of DQL like any other query language. We have SQL, like structured query language, that we use to make queries, for instance, for MySQL. You have KQL, which you use in like Azure environment. Also, other SIEMs like Splunk. Splunk has SPL, its own query language. So a lot of these SIEMs have their own query language. Fortunately, Wazoo is using OpenSearch, and so maybe this will be standardized across many products so that once you learn DQL, you will be able to use that query language for many different products. But it's likely across your cybersecurity career that you're going to have to learn many different query languages. Let's jump back into Waza and conduct a search and look for any event ID 1. So that is data.win.system.event ID :1. This is looking for event ID 1 for Sysmon. If I hit enter, I get no results. We've just identified a telemetry gap. We know that we should be able to find the process create events based on the research that we did about Sysmon. So we have a knowledge that Sysmon has a process create event with event ID 1, and that event should log the command line. Let's jump into our assumed breach host to see if we can enable collecting the process create event. And we're going to open the floodgate wide open and collect all process create events. I have an RDP connection to the assumed breach host where I have that base sysmon config.xml open. And if you recall, at the very top, we have an include where we're only including PowerShell.exe. So what we want to do, since by default process create events would be captured by Sysmon, what we can do is change this to an exclude, and we're not going to exclude anything. We're going to have an empty exclude tag. This will say do not exclude any event that is a process create event, so we will log everything. Now, once I have made this change, I'm going to change my comment to excludes and save this configuration file. The next thing we need to do is tell Sysmon to use this updated configuration file. So I'm going to jump into a PowerShell session that's running as administrator. Now this config file is in my downloads. If I do a dir here, we see the base sysmon config.xml. We need to use the sysmon binary to change the configuration. We do that by typing sysmon, and we're using sysmon 64.exe-c. -c is the option that says update the config to this config I'm going to point you to, which is the base sysmon config.xml. And if everything goes well, you'll see the schema version followed by the configuration file being validated, followed by the configuration updated. This means that we should be logging all Sysmon events for event ID 1, which is our process create events. It won't take long for these events to make it to our manager. So let's jump back into our manager and refresh our search. Uh, As you can see, we've filled that telemetry gap by enabling the process create events for Sysmon, and we are now getting events inside of Waza where we can take a look at the events themselves. Let's expand one of these and take a look at the various fields that we have access to. You can see we have the agent ID, we have the agent.ip, we have the agent.name, which corresponds to the host name. And one very interesting field is this data.win.eventData.command line, which shows the process command line. Let's do some more testing to see if we can generate a command and then find that command in the event data. I'm I'm going to go ahead and jump back. I'm going to go ahead and jump into Mythic. So if I slide over into Mythic, you can see that we have no callbacks. This is because those callbacks quit communicating over time, and I just cleaned up the environment. So we need to get another callback established from our assumed breach host. Now, the first thing I want to do is make sure that our stager is set up on our Kali host. So I'm going to go ahead and go to SSH into the attack Kali host. And we'll cd into downloads, and then we'll use Python to start our simple HTTP server, and that's serving on port 8000. Remember our goodbye AMSI payload, so if we jump back into our assumed breach host and go to downloads, our goodbye AMSI payload is a reflective loader that bypasses AMSI first, uses a PS run space, grabs the Apollo agent and reflectively loads it within that PS run space, and that's how we get our initial access. So let me just go ahead and double click on goodbye AMSI, which will run, and hopefully we get a callback. So let's jump back into Mythic, and we have a callback. Now the reason I wanted to establish a callback is I want to run a command that we hopefully get logged that we can find within the Waza manager. So I'm going to go ahead and interact with this callback, and we'll use a shell command. So shell, and we'll run net local group administrators. And we'll send that. You can see it's been submitted. The agents picked it up for processing. And we got results, but we did the command net local group admin. I spelled administrators incorrectly. So let's try this again. And you can see we get our results back for local administrators on the assumed breached host. Let's jump back into the Waza manager. We're still at the explore, discover, and we want to modify this search to add additional criteria for search. So what we want to do is use an AND. An AND is a Boolean operator that states that both conditions on the left and right side of the AND must be true for the compound Boolean expression to evaluate to true. The other part of this query is we want to take a look at this command line field and look for local group. So that field is data.win.event data.command So we want to say where data.win.event data.command and we're going to look for local group, but we're going to surround it with asterisks and run that. And now let's check and see if we just get these local group. And you can see it is highlighting the command line that it's matching on local group. Now we typed this command a few times because we made a mistake. So we should see our error in here also. I'm just looking for our error, which is right here. So we found both of those commands that we issued, and those have been logged in WASA. Now this is the beginning of figuring out how to write a detection for some of the enumeration commands that are used by attackers. Let's see if we can get this same process working for the Network Connect. So the Network Connect events for Sysmon is Event ID 3. Let's go ahead and take a look and see if we see any Event ID 3s. We'll go ahead and update our search, and we currently have no results. Here again, we've identified a telemetry gap. Now let's jump back into our assumed breached host. And what I want to do is open up Wireshark. I just want to show you part of like what we're going to do in future lectures as part of tracing. I'm going to go ahead and open up for the Ethernet adapter here, and what we'll do is filter on HTTP and hit enter, and you can see that there are these connections being made. This is our beacon. So our beacon is connecting out to our attack infrastructure at 192.168.100.101. So it's posting data that direction from internal to external, and then it is getting a response. So we know that this is using HTTP, which is port 80. We also know that Sysmon has a Network Connect event. Now the Network Connect event is Event ID 3, and by default it is disabled. Now we're going to be more explicit here on what we want to include. What I'm going to include is anything that goes to destination port. So destination 80 will capture our beacon traffic. Now let's go ahead and add some other destination ports here. Let's do port 443 in case they're doing HTTPS. Another one would be SMB would be a good port, so 445. And let's keep these in order. And let's do 135 for RPC. So these are some of the connections that we want to capture. Now there's ways to make it wide open and capture all network connections, but that would be an extreme amount of event volume. Think of all the DNS, the ARP, all that is going on within the environment. So now that we have these rules updated, we're going to include anything for port 80, 135, 443, and 445. Let's go ahead and save this config, and then I'll jump into my session, my PowerShell session that is open as administrator. And type clear there. So this is our base sysmon config. We'll use sysmon config, our sysmon 64.exe -c and point to our updated config. Now everything looks like it loaded correctly. One thing that you can do for troubleshooting is to make sure that these events are getting captured within the event viewer. Since I'm running as administrator, I can type event VWR and hit enter, and that will open the event viewer. We can then expand the application and services logs, Microsoft, Windows, and then look for Sysmon. Expand that and click on operational. Now we can filter here by event ID. We're going to go ahead and filter current log, and then we'll select ID 3 for event connections, and you can see that we're getting some network connections. And you see that this was on port 135. So that was MMC, but I don't see the port 80s. Now, Since the beacon was created before we updated the Sysmon config, it might not capture that traffic. Let's go ahead and start another beacon here. Let's go to Downloads and double click on Goodbye AMSI, and that will establish a new callback. So if we go back into Mythic, we got our new callback. Let's go ahead and refresh this and see if we're getting any port 80 connections. And here you see that we are capturing the port 80 traffic to the target attack infrastructure. And we can see the image that is communicating to that attack infrastructure is goodbyeamc.exe. That's perfect. Now it shouldn't take too long for this data, this event data, to make it over to the WASA manager. So let's go ahead and jump into the WASA manager and see if we can find these network connect events. All right, so now we have our search here. Let's see if we refresh if any network connect. Now it may take a little bit of time for the agent to check in and to get some event ID 3s over, but they should populate here shortly. And we finally see the events show up. So let's take a look at this top event here, which looks like it's reaching out to our attack infrastructure here at 192.168.100.101. Let's expand this. And one thing that we can see is there's a destination port. So if we wanted to filter down, we could filter down on destination port. Now we've successfully identified two telemetry gaps, both for process create and network connect events, and we've fixed those telemetry gaps by enabling logging with Sysmon and then making sure those logs are being forwarded to our WASA management environment where we can run queries and explore that data. Before you move on to the next lecture, make sure you can see your commands using Sysmon Event ID 1 and make sure you can see network connection events from your Apollo agent using Sysmon Event ID 3. In the next lecture, we're going to take a look at enabling Sysmon Event ID 7, which we can then use to find untrusted code. And if we combine that with network connections, we can work towards a high fidelity detection for some beaconing activity.